This is Algebra Lesson 7-5, Linear Inequalities. Linear inequalities are similar to linear equations with just a few little tweaks here and there. A linear inequality is a region of the coordinate plane that has a boundary line. The equal sign has been replaced with a greater than, a less than, a greater than or equal to, or a less than or equal to symbol. Which means when you graph, you are going to have to determine whether or not you have to be able to differentiate whether it's a greater than or a greater than or equal to. And I will show you on the graph how to do that. The solution of an inequality is the coordinates of the points that make the inequality true. This is done by shading. The graph of a linear inequality is the region of the coordinate plane bounded by a line. Every point in the region is a solution to the inequality. This is shown by shading a graph. A solution to a system of linear inequalities is any ordered pair that makes each inequality in the system true. To solve a system of inequalities, graph the inequalities on one coordinate plane, shade either using two different colors or two different directions, and where those two shadings cross, that would be the solution. Now, the only real difference between graphing linear inequalities and linear equations is the boundary line. Okay, very important. The boundary line does change. Okay? In an equation, the line is always solid. In an inequality, the boundary line is solid if it's greater than or equal to or less than or equal to. The boundary line will be dashed if the inequality is greater than or just less than. That's the major difference. When you graph a line, you will always make it solid. Now when you're graphing an inequality, it's only a solid line if it's greater than or equal to, because what that is telling you is that if a point lands on the line is also part of the solution, which is where the equal to comes in. But if it's just greater than or less than, then the boundary line is not part of the solution. Okay? It's kind of like in some sports. In volleyball, if the ball lands on the line, it is out. In soccer, in order for the ball to be out, the ball has to cross the line by more than half the ball. So the boundary line for soccer, the line is actually in until the ball goes over halfway across that line, and then it's out. That's the difference between your boundary lines. There are some steps to graphing linear inequalities. You need to make sure you copy these down. Step one is to graph the boundary line. In other words, graph the equation with the proper dashed or solid line, using any form of graphing you shall choose, slope intercept, intercepts, picking the points under making a table, whatever. Test a point on the boundary line. 0, 0 is a great test point as long as the line doesn't go through that point. If the test makes the inequality true, shade on that side of the boundary line. If the test point does not make the inequality true, shade on the other side, and then label all your graphs. Let's go through some examples. Let's graph the following inequalities. This first one here, y is greater than or equal to 3x minus 1. First thing we need to do, draw in our x and y axis. And of course, you should label those. Always, always, always label your axes, because now it's going to be even more imperative that you label them, because we're going to have boundary lines and shading and all kinds of things that can mess up. Let's treat this like this is y equals 3x minus 1, just for the graphing portion. So the first thing I'm going to do is I know my slope. My slope is 3. My y-intercept is -1. So I'm going to graph that. I'm going to start at -1, and my slope is up 3, right 1. This is a solid line because it has the equal to symbol right there. So you know it's going to be a solid line. And again, I would highly encourage you to use your rulers. Okay, I am going to try to do this to the best of my ability. If I can get my line to go through. Okay, you should have everything on both sides, but sometimes it's hard to do. I just want to rotate it just a little bit. You can see it's really hard to do this. Okay, so let's just. There we go. There's my lovely line. I'm going to put an arrowhead on this end of it. Here. Oh, just move it. There we go. So now I'm going to put an arrowhead on. I did it again. I moved it. I should lock it in place now. There we go. There's my line. Now when I put my arrowhead on it, Now I need to figure out where to shade it, right? Which way to go. I'm either going to shade down here on this side, or I'm going to shade on this side. Okay, I'm going to undo all those so I don't mess up my graph. To figure that out, we do what's called a test point. The easiest test point to use is 0, 0, provided the graph does not go through 0, 0. It doesn't. It doesn't go through the origin. It's close, but it doesn't. So I'm going to test the point 0, 0. It's easy to test 0, 0. You just put in a 0 for y and a 0 for x and see if it makes a true or false statement. So I have 0 is greater than or equal to 0 minus 1. Is 0 greater than or equal to negative 1? Yes, it is. 0 is equal to negative 1, is greater than negative 1. Therefore, this is true. So you shade where 0, 0 is. 0, 0 is on this side of the graph, so I'm going to shade on this side of the graph. Okay? And of course, you should label your graph. Y is greater than or equal to 3x minus 1. So you graph originally just like you graphed before, making sure you pay attention whether it's a dashed or a solid line, and then you shade to tell me where. So now what this is saying is any point where I have shaded is a solution to this inequality, and we can choose one. Let's choose, I'm going to use my red, let's choose this point right here. This is the coordinate of 1, 2, 3, negative 4, 0, right? According to my shading, negative 4, 0 should make this a true statement. So x is negative 4 and y is 0. So 0 is greater than or equal to negative 12 minus 1. 0 is indeed greater than or equal to negative 13. So it is true, isn't it? This is a way to test, to make a double test to make sure that you've actually shaded in the right part of your graph. Let's look at equation number 2 here. Y is greater than negative x plus 3. And again, I'm going to draw my x and y axes. There's my x. There's my y. I'm going to plot using slope-intercept. So I have my intercept is 3, 1, 2, 3. So here, my slope is negative 1 over 1. So down 1, right 1, down 1, right 1, down 1, right 1. Now here, oops, I missed. Going down to the right one. Here, what we need to do is, if you get carried away, you might go, oh, there's my line. Oh, shucks, I just realized that this is supposed to be a dashed line. Dash it all, I didn't dash it very well. It's a little harder to dash with this eraser. Okay, so you might want to have to bring it in and dash it. So the easiest way to do this is to recognize right away, it's a dashed line. Okay, I'm going to try to do this here, so I'm going to use a dashed line. Actually, I'm going to use this color because it happens to be dashed on both sides. So, there we go. That looks about right. So there's my line. Pretty little line, isn't it? Now I need to test to see where I should shade. Okay, it's got to be a dashed line because the boundary line is a dashed line. If you forget and make it solid, take your eraser and erase parts of your line so that you can make it dashed. Now I'm going to test the point 0, 0 because 0, 0 is definitely on one side or the other side of my graph. So I'm going to test 0, 0. Okay, 0 is greater than 0 plus 3. Is 0 greater than 3? That's a false statement, isn't it? So I'm not going to shade where 0 is. I'm going to shade where 0 is not. Okay, and 0 is not on this side of the graph, so I'm going to shade on this side of the graph. And you don't have to shade so thick that people can't even read what you've written underneath or read the points. Okay, last thing you should do is label your equation. Y is greater than negative x plus 3. Simply done. Let's skip 3 and go to 4. Oh, let's do 3 here. Well, might as well. Good practice. All right. Again, I'm going to use slope-intercept. Okay, there's my x. There's my y. So I cross the y-intercept at negative 4. 1, 2, 3, 4. My slope is positive 2, up 2 over 1, up 2 over 1, up 2 over 1. Okay. I wanted to dash my line. Okay. That's not very straight at all. That's why I don't. Okay. I like to use rulers. Very, very important to use a ruler. I'll go back to this guy here. Let's pull this one again. Okay, so I will, there's my line, I gotta straighten it out now. I will adjust it ever so slightly. Just touch this way, just touch that way, so it touches all my points. There we go, that was better. There's my line. Now I need to test. I can test 0, 0. Oops. So I have 0 is less than 0 minus 4. 0 is not less than negative 4. That's a false statement. So I'm not going to shade where 0 is. So I'm going to shade where 0 is not. And just for fun of it, I'm going to shade this in this color here. So there we go. I'm shading where 0, 0 is not. And the last thing I'm doing is I'm going to label my equation. Y is less than 2x. And there you go. A nice colorful little graph. Now, if your graph is not written in y equals form, you can either choose to write it in y equals form, or you can choose to use intercepts. This one doesn't work really well with intercepts because 9 is not divisible by 4 very nicely. So I'm going to rewrite it in y equals form. So I have negative 3y equals negative 4x plus 9, and I'll replace the equal sign in a minute. Divided by negative 3, divided by negative 3, divided by negative 3. I divide it versus my inequality sign, so maybe I should put that in there. There we go. There's my inequality sign. So if I divide by negative 3, I get y. Instead of greater than or equal to, it's now less than or equal to positive 4/3 x minus 3. So there's my graph. So there's my x-axis. There's my y-axis. Keep this in the middle line up to the top. So negative 3, 1, 2, 3 down here. Positive 4, up 4, 1, 2, 3, 4, right 3, 1, 2, 3. Up 4, 1, 2, 3, 4, right 3, 1, 2, 3. So there's where my graph should go. I'm going to choose my lovely line here. Up 4, 1, 2, 3, 4, 1, 2, 3, there. That blue line there, it should not be there. So there we go. 1, 2, 3, 4. Right, that's pretty spot on for once. So I will lock my line in place. I messed it up. Go over here. Always extend your line all the way through the graph. Okay, so there's my graph. I can test my 0, 0 points. And it doesn't matter, I can test it in the original equation here. Or I can test it in my equation that I just wrote. It doesn't really matter. I'm going to test it in the original. 0 minus 0 is greater than or equal to 9. 0 is not greater than or equal to 9. That would be false. So I'm not going to shade where 0, 0 is. Okay, which means I'm going to shade down here. And I should label my equation, last but not least. Y is less than or equal to 4/3 x minus 3. Or I can write it with the original, it doesn't matter. Alright, suppose your budget allows you to spend no more than $24 for decorations for a party. Streamers cost $2 a roll, and tablecloths cost $6 each. Use intercepts to graph the inequality that represents the situation and find 3 possible combinations of streamers and tablecloths to provide. So there are no equations here, but we need to write some equations. Okay, so if we need to write some equations, it would be to our advantage to make sure we have some variables. So I will define my variables. I'm going to let x equal streamers. And I'm going to let y equal tablecloths. Alright, and it says that we can spend no more than $24. So we have our equation should be based on money. Streamers cost $2 a roll, so $2 times the number of streamers I buy, plus $6 times the number of tablecloths I buy, can spend no more than 24, which means I could spend 24, but I can't spend more than 24. If you remember, This means at most $24, which is at most means less than or equal to 24. That's what at most means. We talked about this before. They told us we should use intercepts, which is nice because 24 is divisible by 2 and 24 is divisible by 6. So if I use intercepts, if x is 0, 24 divided by 6 is 4. If y is 0, 24 divided by 2 is 12. Now, I know I cannot buy a negative amount of streamers and I cannot buy a negative amount of tablecloths. So that I know I don't need anything but quadrant 1. So I'm going to use quadrant 1 here and only quadrant 1. So I'm going to draw my axes. And I can easily call this, I can call this my x-axis and I can call this my y-axis. And I can even label my axes and I can call this streamers, number of streamers. And I can label this number of cloths. And I'm using intercepts, so my x-intercept is, okay, x-intercept is 0, 12. Y-intercept is 4, 0. Or plot, remember you can always just read the points, plot the point 0, 4, and then plot the point 12, 0. Okay, so my x-intercept is, okay, I cross my x-axis at 12. Okay, excuse me, I got that wrong. Not 0, 12, well that's the point. I cross the x-axis at 12, and I cross the y-axis at 4. Okay, so x-axis at 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's where I cross the x-axis. I cross the y-axis at 4. 1, 2, 3, 4. Or in other words, the point 0, 4 and the point 12, 0. I can draw my line now. And this is an equal to, so it's a solid line. Okay, so I need to be drawing a solid line here. Let me adjust my line. The person should bring my line. Lock it in place here. Move when I'm playing with it. Means I can add arrowheads to it now. Oops, I'll make my pen working. So there's my line. Less than or equal to means most likely 0, 0 is going to work. 0 is definitely less than 24. So this would be the area that I would shade. I'm going to be shading in this area right here, this triangular area. So this is all the possible solutions to my inequality. What they want to do next is they told me to find 3 possible combinations of streamers and tablecloths that I could buy, which means I can choose any 3 points that land in this triangular region. Okay, I'm just for arbitrary sake, I'm just picking those 3. Okay, and if I read that, I can buy 0 streamers and 2 tablecloths, and I can write 0 streamers. Oops. Not streams. ERS. 0 cloths. I can buy 1, 2, 3, 4, 5 cloths. 0 streamers. And I could buy 2 streamers and 2 cloths. And that is 3 possible combinations that they asked me to find. And anything that lands inside of this triangle, the red triangular region that I shaded right here, that would work for a solution to this inequality.